All right, good morning. What we're going to look at today is how you solve the parallel challenges in Basic Circuit Challenge program. And what I got here, what you're seeing in front of you, this is a screen from Parallel Circuits 1. Before we start into that, let me go here. Here's the parallel order of operations. The first thing you want to do in parallel is not add the resistors. That's what you do in series. Parallel, as the total resistance is going to be a value very different than the resistor values that you have. You want to take your input voltage, that's what's powering the circuit, and divide it by the individual resistor values. Instead of that being the case of parallel 1, IR, the resistor value of resistor 1 and 2 to get the current value across those resistors. So let me go back. Okay, so right here, so here's your voltage value, 120 volts, and you got a 60 ohm resistor and a 20 ohm. So the 120 divided by 60, you get 2 amps for IR1, and you're going to get 6 amps for IR2. So that's how you get the first step that you want to do in the parallel. Next thing you want to do in parallel is you want to add those resistor currents up to get IT. So the 2 and 6, they add together to get 8. Once you have the current total, now you can get the resistance total. So you do that by dividing the input voltage by the current total. So right here, there's I. So you divide the voltage, 120, by 8, you end up with 15. I want you to notice is that the resistance total, 15 ohms, is smaller than any of the resistors in that circuit. That's something that's true in parallel. The total resistance will always be a smaller value than the lowest value resistor in the circuit. So that's actually why you can't just add the resistors. That's what you do in series. So parallel is much harder to do on the resistance side. After that, it's kind of easy. Okay, so you're going to do that. Let me go back to the order of operations. Okay, so we got resistance total. Then you want to get your individual resistance. Well, it's a parallel circuit. This is so easy. Parallel doesn't change voltage. So parallel changes current, does not change voltage. So the voltage value in the circuit is the same everywhere. So if you know it one place, you know it every place. So VR1 and VR2 are what's powering it. So incredibly simple. The next thing you want to do in parallels after you got that is get the power. And power, just like in series, in fact, my picture here, this is actually from the series exercise, is the voltage multiplied by the current. That's how you get power total. And this one's also from series. It said the resistor powers are the current across the resistor and by the voltage across the resistor. Same way it's done in series. And series or parallel, the power values of the resistors add up to the power total. So that's basically it for right now. Have a great day. See you next time.